So talking about functions a little bit more. One thing that's important is that though we use a lot of formulas in this class, there are other ways to represent a function besides just with an explicit algebraic formula. Okay, so for example, if I want to say verbally, if I want to express function, let's say take a number and multiply it by itself, for example, right? Right, that's my friend x squared, okay? So there's my verbal expression. I've just explained the rule. Numerically typically means with a table of values. So we could do it like this, right? You could do this. X, Y, 1 goes to 1, negative 1 goes to 1, 2 goes to 4, negative 2 goes to 4, etc. You can see I don't have very many there because I don't want to write very many also, but whatever, it gives you an idea. You will often use a numerical expression, numerical data, for example, in a word problem, or perhaps we're trying to approximate something with some real data. They give you some data and you're trying to approximate it. So you'll see that in this class occasionally. Visually, of course, means with a graph. So with my y equals x squared, I've just done this. And algebraically means with a formula. So y equals x squared. Okay. Now for all of, now you see though, all right, it's still a little bit not quite clear. That's why from the previous video, the domain and the range is important, right? Or the domain and the codomain, presumably the domain really. So from here, if I have this numerical table of values, I don't know, besides these 4 points, if I'm only interested in those 4 points, or if I'm interested in all the integers, or if I'm interested in all the real numbers. The way I drew it for all real numbers, and I wrote this down. If you see it written down like this, because we're in calculus and we're going to take the natural domain, you can assume it's all real numbers. But really, the best way to be precise is by using the notations from before. So if this is really what I want, then I can write f from r to r and f of x equals x squared. So now this is precise. I know I want this one. I know I don't want only 1/2 or another half or just some points or whatever. Okay, so that's why for the most part we will be using these algebraic formulas, and we will be using the convention that unless they specifically define a domain, it's going to be the biggest possible domain for the function. Okay. So that's 4 ways to represent a function. And as I said, so we will see those. Now, let's talk a little bit about some other examples of functions, because so far I've only got this guy up here. And there will be another video where we go through sort of the basic common functions that we'll be using. So I'm not going to do that right now here, but I wanted to do an example with some piecewise defined functions. That's something that we'll see a lot in this class, and that's something that occasionally is confusing. So piecewise defined functions, as I'm sure you remember, are ones where the rule is different on different parts of the domain. So for example, I've got one here that just has some very basic functions, and I wanted to just kind of look at some features of this graph and just sort of discuss it so that it's you know, is a nice example here. Okay, so I'm given this, and we're just going to graph it. So we kind of have, so that here's our algebraic definition, and we're going to graph it so that we have the visual definition, and then we'll talk about some of the features of this graph. Okay, so as I said, we're going to assume that the domain is as much as it can be, right? So I'm going to try to go negative infinity, infinity, more or less here. And I'm going to think about what this function looks like on these different parts of this graph. Okay? So if you know how to do these, you don't have to do them, you don't have to draw them separate like I'm going to. You can do them in your head. But if you're confused, sometimes it's good to draw them separate. So this first one, that's just a constant, right? So that's just the constant value of -2. I'm going to take value of -2 all the way. So the y value is -2. For x value is all the way to -2. So that would be right here. Notice it's also including -2 right there. So I have a closed circle there, which is going to tell me that this point, the point at -2, is still here with this part of the definition. Now this next part of the definition is absolute value of x. Absolute value of x, of course, graphically it looks like this, but absolute value of x is itself a piecewise defined function because absolute value of x means x when x is positive and negative x when x is negative. And of course it's 0 at 0, right? So this is itself a piecewise defined function, and then we're using that piecewise defined function in my bigger piecewise defined function. So I basically want my function to look like this, and I want it to look like that from -2 to 2. So this here is going to be like that. Now notice, oops, here the -2 and the 2 are not included, so I'm using the open circle. Okay? You can see it jumps here, it does this, and now what is the last part? The last part is just some line. Let's see, 1, 2, 3, right? So 1, 2, 3, 4, 5. So at 2 it's 5, and I can just plot points, right? At 3 it's 8, and I'm up here, whatever. So it's a line like this. So 1, 2, 3, 4, 5. I didn't make my graph big enough. 1, 2, 3, 4, 5. And then at 3 it's going to be 8. So that's going to continue on. Okay. Out of the picture. All right. All right. So this graph has a couple of things that I want to talk about. First of all, if you're asked for the domain, you'll notice that the natural domain of this, every point is defined except for one point. The point at x equals 2 has not been defined. We just don't know what it is. They didn't tell us. So that means that when I go and answer the question, what is the domain of this function, I can't just say it's all of R. I have to get rid of that point. Okay? That point is just because it's not been defined. They didn't tell me what it was. Now, why am I doing it like that? Oh, because I was thinking the other sets. All right. So if I want to write this down in interval notation, which is what WebAssign will always ask you to do, by the way. They love the interval notation. So I write this down like all the stuff before 2 union with all the stuff after 2. I can't use this guy because if I use that, this implies that I'm including the point at 2. So the open bracket, the parenthesis, tells me I go all the way up to 2, but I don't include it. So I don't want that bracket. And the other thing is, I don't want to write it like this because there is no point at infinity. Like infinity is not a point, it's a limit. So the end, if it's positive or negative infinity, the end should always be an open bracket. Okay, so that's my domain. If the definition was different, if it was equal there, or if we decided, or whoever wrote this problem decided to give this thing another point, like put it there, then my domain would be all real numbers. Okay, so I wanted to point that out. Another thing I wanted to point out, and this is actually quite important when you do these kinds of problems, it's a very easy mistake to make. Notice when I drew, like, and as I said, these are pretty easy, so you might not even have to draw them, but if they were more complicated, you might want to draw them. Notice when I drew it, I drew them separately. I didn't draw them on my graph. The reason I didn't draw them on my graph is because I didn't want to forget and have all kinds of wrong lines everywhere, right? So if I just drew it on the graph, let's say I just drew it like this. This is completely wrong. Why is it completely wrong? Because this is no longer a function, right? You can see this picture completely fails the vertical line test. It completely fails that bit that we said in the definition that each point only gets sent to one place, right? Because look over here. My point at x equals -3, here my picture looks like it's being sent both to -2 and to +3. So if I'm not careful, I'll get a bad picture, a picture of something that's not a function. And if I were to be, you were doing this in a test, you would not be getting any credit for this because I asked you to draw a function and you gave me something that was not even a function. You should be able to recognize immediately at this point when you draw something that is not a function. So that's really the important thing. That vertical line test, do remember that it's really important for your function to be uniquely defined.